Okay, now let us look into another very simple problem, which is subset GCD. So this is again a math based problem. So let us look into the problem statement first. So here we are given two integers n and k, and we want to find k sized subset of the set going from 1 to n. So we want to find the k sized subset of the set where the numbers in this set will go from 1 to n, and we want to make sure that this k sized subset has the maximum GCD. And if there are, so they have given that if there are multiple such subsets which exist, then you can print any of them. So I hope that the problem statement is quite clear. So we are given the set which goes from 1 to n. We want to find the k sized subset of that set such that the GCD of that k sized subset, I mean the GCD of the numbers within this k sized subset is maximum. So yeah, and then they have given the input format and output format. So in the input format, they have given that first integer denotes the number of test cases, and followed by that for each test case we have two integers n and k, as we discussed, as we saw in the problem statement. And for the output format, they have given that for each test case we have to print k space separated integers, which is nothing but the k sized subset of the set, right, of the set going from 1 to n, like having numbers from 1 to n. So we have to print the k sized k integers space separated integers denoting the subset k sized subset with maximum GCD. And again, if there are multiple such subsets, then we can print any of it. And yeah, one more point that they have given here is that the elements of the subsets can be printed in any order. For example, 1 2 3 same as 2 1 3, so they are considered as identical. And followed by that, they have given the constraints like t can vary from 1 to 10 to the power 5, and k is less than or equal to n, and both k and n vary from 1 to 10 to the power 5. Okay, so let us understand this problem statement even better by looking into the sample inputs and sample outputs. So here they have given the sample inputs. So there are three test cases here, and the first test case is 3, 2. So n is 3, k is 2. Then n is 3, k is 3 for the second one. For the third one, n is 4, k is 2. And for each of them, they have given the output as 2 3, 1 2 3, and for the third one it's 2, 4. So these are the k sized subset for the above test cases. So now let us go to the whiteboard and see how they came up to this answer. So for n equals to 3 and k equals to 2, so we have the original set from 1 to 3 like this. So this is the original set, and we want to we want to have the subset of size 2 from this given set, such that the GCD is maximum, right? So here in this case, for this original set, there are three possible ways in which we can get the subset of size 2, right? It can be either 1 2, it can be 2 3, or 1 3. And you observe the GCD of each of this set, right? If you see, GCD of each of these three set is 1 only. So that is what is the maximum GCD that we can get by picking any of the subset of size 2. So in this case, they have chosen any of it. So they have mentioned clearly in the problem statement that if there are multiple answers, then we can print any of it. So in this case, they have chosen the second one, this one, right? And they have printed that as the answer. Now for the second test case, right, this is test case 1, this is test case 2, right? The second test case, n is 3, k is 3. So now when n and k are equal, we have no choice but to select the entire set as the subset, right? So this is the original set going from 1 to 3, because n is 3 and k is also 3, right? So in this case, we have no choice but to pick the entire set, which is 1 2 3, and that is what is the answer. which is given, right? So that is the second test case. And for the third test case, what they have given is n is 4, k is 2. So here in this case, n goes from, the set is this, right? It goes from 1 to 4. It has numbers from 1 to 4. And we want to choose the subset of size 2 such that the GCD is maximum, right? Now in this case, for the set with numbers from 1 to 4, we can again pick many subsets which are of size 2, right? One can be 1, 2, 2, 3, 3, 4, right? 2, 4, and so on, like many of it, right? But if you see, out of this, all of this subset, if you see, for example, for this, the GCD is 1. Again for this one, the GCD is 1. Again for this one, GCD is 1. But for this one, if you see 2, 4, the GCD is 2. So GCD of 2 and 4 is 2. And hence, and this is the maximum GCD. You can try even more combinations, but you won't be able to find a set of size, subset of size 2 from this original set such that GCD is greater than 2. And hence, this is printed as the final answer, which is 2, 4. So in general, now I think we have the we have the rough idea of what is the problem statement. Now let us brainstorm over the solution part, right? So for that, let us pick one good example so that we can get the gist of how we will solve this problem. So here, let us say that we in this case, for this test case, let us say that n is 9, right? So we have numbers from 1 to 9 in the original set, 5, 6, 7, 8 and 9, right? And let us say that let us assume multiple scenarios for k. Let us say that k is 1, k is 2, k is 3, k is 4 and k is 5. Now for each of this scenario, right, for the single value of n, we are assuming multiple values of k, and for each of this scenario, let us try to find the solution for the given problem statement, right? So for k equals to 1, which will be the so since k is 1, you can pick the subset of single value, right? Because k is 1, so subset which is of size 1 from this original set, which has maximum GCD. So what will you pick? You will definitely pick 9, right? So this is the set. This is the subset of the original set going from 1 to 9, having number from 1 to 9. And this subset, which is of size 1, has the maximum GCD, which is 9 again, right? So this is the answer in this case, right? This is the final subset. Now for k equals to 2, right? For k equals to 2, you need to select the subset of size 2 from this original set such that GCD is maximum. So which one will you pick? If you observe carefully, if you want to pick two numbers or two elements from this original set, right? Two numbers from this original set such that GCD is maximum, then it would be 4, 8. You can try other combinations as well. Try picking two numbers other than these two, or any two combinations out of this entire set of 9 numbers here, and you'll find that the GCD of those two numbers will be less than or equal to 4. So here the GCD is 4, right? GCD of 4 and 8 is 4. So again, the answer here is 4, 8. And for k equals to 3, if you see, which is the number, which is the subset which is of size 3 that you will pick in order to get the maximum GCD. So in this case, the answer would be 3, 6, 9, right? And the GCD of these 3 numbers will be 3. And you can again try multiple combinations. That is, you can try creating multiple subsets of size 3 out of this original set, right? And you will find out that the GCD of those 3 numbers, out of all of the subsets that you have created, will be less than or equals to 3. So this is the maximum GCD that you can obtain for the subset of size 3, and hence this is the answer, 3, 6, 9. So now let us also try for k equals to 4. So for k equals to 4, what you will do is, what will the answer, right? So for k equals to 4, for picking up the subset of size 4 and making sure that its GCD is maximum, you need to definitely pick up 2, 4, 6 and 8, right? So okay, yeah, so this is the subset that you are picking, right? 2, 4, 6 and 8, and GCD here is 2, right? So now yeah, again you can try multiple subsets of size 4 and you will see that for all of them GCD will be less than or equals to 2, and hence this is the optimal solution here, 2, 4, 6, 8. And for 5, what will be the GCD? What will be the subset of size 5 such that GCD is maximum? So you'll find that it will be 1, 2, 3, 4, 5. In this case, actually, you can pick up multiple subsets as well, right? So this can be 1 for which the GCD is 1. Again, you can pick 5, 6, 7, 8, 9, right? For this also GCD will be 1. But yeah, for the sake of simplicity, we can print this one also, right? Because in this case, for subset of size 5, the maximum GCD that you can get is 1 only, and that you can get by picking up any subset like this one or any of it. So the whole idea of doing this entire exercise is this, right? So here you can observe a pattern here, right, by solving this test case, right, for n equals to 9 and k equals to 1 to 5. So there is this interesting pattern here. If you see, for k equals to 1, what you'll get is that you need to just get the multiple of 9. For k equals to 2, you need to get multiple of 4, right? Multiple of 4 and 8, right? Here it was multiple of 9, but just we need one element, so that we printed 9. Here we need multiples of 4, which is 4 and 8. Here we need multiples of 3, which is 3, 6, 9, right? Here we need multiples of 2, which are 2, 4, 6 and 8. And here, and in this case, we need okay, let me rub this one so that it can be more clear. Rub this part here. Right? So here we need okay, and here in this case for k equals to 5, we need multiple of 1, which is 1, 2, 3, 4 and 5, and multiples of 1. So the thing is simple, right? Here we need multiple of 9, multiple of 4, multiple of 3, 2 and 1. But how do we decide this value, right? How do we decide for which value we need the multiple? Here we need for 9, here we need for 4, here we need for 3, here we need for 2 and here we need for 1. So here again we need to use our observation. So how does this 9 value come, right? So here n is 9, k is 1. So if you do n by k, which is 9 by 1, you will get 9, and that is what is written here. We need multiple of 9. Again here n is 9, k is 2. So 9 by 2 is 4, and hence we need multiple of 4 here. Here again 9 by 3 is 3, and hence we need the multiples of 3 here. 9 by 4 is 2. Here we are considering the integer division, and hence 9 by 4 is 2, and hence we need multiples of 2, and similarly for this case. So I hope now the solution is getting clear in our head, right? What we need to do essentially in this problem is that we need to first of all figure out n by k. We need to get the start value, right? We'll say this n by k as the start value, and for the start value, after figuring out the start value, we'll find all the multiples of all the, not all, but we'll find, let me rub this part. We need to find first k multiples first k multiples of start, right? So for example, in previous case, right, for n equals to 9 and k equals to 3, our start was 9 by 3, which is 3, right? Our start value was 3, right? And first k multiples of start, so first 3 multiples, k is 3, right? So first 3 multiples of 3, which is 3, 6 and 9, and that was what our answer was, right? So I hope this solution is clear, right? So this is how we approached this problem, right? We solved a couple of examples and we came up with a general pattern and we figured out the solution. So now let us jump into the coding part as well. So okay, let me move here. Yeah, so here is the solution, right? And again, the code is very simple. So what we are doing is that we are declaring few variables here, n and k. We are taking n and k as input here, and then we are declaring the array to store the final result, that is the subset of size k, right? So that will be stored in this array ARR, which will be our final result. Then we are calculating the start value, right, which is n by k. We saw in the whiteboard part, right? So we are defining the start multiple here, which is start value, which is n by k. And then we need to compute the first, right? This is first k multiples of start. So that is what we are doing here, first k multiples of start, and we are pushing that values in the ARR array, which is the array which will hold our final result, and then we are finally printing the final result. So yeah, so that's pretty much it. So this is the final code, and yeah, this will produce the expected result. So yeah, with this we are towards the end of this video. I hope you like this video. So do press the like button and subscribe to the channel. Thank you.